the tale of matter and antimatter. Long ago, in the heart of the universe's creation, two twin forces were born, matter and antimatter. They were identical in every way, except for one key difference. Matter was positive, and antimatter was its mirror opposite, negative. At the dawn of time, when the universe exploded into existence, matter and antimatter danced together in perfect symmetry. But there was a problem. Whenever they met, they annihilated each other in a burst of pure energy. For every electron, there was a positron. For every proton, an antiproton. It seemed like the universe would remain empty, with both forces canceling each other out. But somehow, in ways still mysterious to scientists, a tiny fraction more matter survived than antimatter. And that small imbalance became everything we know: the stars, the planets, and even us. Who discovered antimatter? In 1928, a brilliant physicist named Paul Dirac was studying the strange world of quantum mechanics. His equations suggested that every particle should have an opposite twin with the same mass but opposite charge. Many doubted him, but in 1932, an American scientist named Carl Anderson discovered the positron, proving Dirac's theory correct. Later, scientists also discovered the antiproton in 1955 and antineutron in 1956, confirming that antimatter was real. Why is antimatter important? Though rare, antimatter has the power to unlock many secrets of the universe. Scientists believe it could explain why we exist. If equal amounts of matter and antimatter were created at the Big Bang, why did matter win? Revolutionize energy. Matter-antimatter annihilation produces enormous amounts of energy. Just 1 gram of antimatter could release around 90 terajoules of energy, which is roughly equivalent to 25 kilotons of TNT. That's enough to power a city for an entire day. Advanced space travel. In the future, antimatter could be used to create antimatter-powered engines, potentially allowing us to travel to distant stars. Theoretically, antimatter propulsion could reduce travel time to Mars to just a few months. The cost of antimatter. Creating antimatter is extremely difficult and expensive. To give you an idea, producing just 1 milligram of antimatter could cost around $25 billion. The reason is that producing antimatter requires huge particle accelerators like those at CERN, where atoms are smashed at incredibly high speeds to produce tiny amounts of antimatter. Even with advanced technology, this is an energy-intensive and costly process. Real-world uses of antimatter. Despite its high cost, antimatter is used in medical imaging. Positron emission tomography (PET) scans rely on positrons to help doctors detect tumors and other diseases by imaging how the body absorbs radioactive substances. This shows how even small amounts of antimatter are incredibly useful for humanity. Today, antimatter is still a mystery to scientists, but its potential to revolutionize energy, space travel, and medicine is enormous. Though it is extremely expensive and difficult to produce, research continues in the hope that one day antimatter might help us unlock the deepest secrets of the universe.